Stand at the edge of any runway in the world and look down at the numbers painted on the threshold. 2 digits, large enough to read from a cockpit at low altitude, positioned precisely at the point where the usable runway surface begins. On the opposite end of the same strip of asphalt, a different pair of digits. The 2 numbers are always exactly 18 apart. This is not a coincidence, not an administrative code, and not a sequential identifier. Every runway number on every airport in the world encodes a single piece of information: the direction the runway points, measured in degrees from magnetic north, rounded to the nearest 10, with the final 0 removed. Runway 09 points east, 90 degrees on a compass. Runway 27 points west, 270 degrees. Runway 18 points south. Runway 36 points north. The opposite end of any runway always differs by exactly 18, because 180 degrees is a half rotation, the same strip of pavement pointing in the opposite direction. A pilot lining up on runway 09 is heading east. A pilot on the same pavement from the other end, designated runway 27, is heading west. The number tells them this without requiring a map, a chart reference, or a radio call to confirm orientation. The system is more useful than it first appears. During approach, a pilot who has been cleared to land on runway 23 knows immediately that the runway points approximately southwest, 230 degrees. If the wind is reported from the northwest, that pilot can calculate the crosswind component mentally before the runway comes into view. The number is not just a label. It is navigational information, encoded directly into the identifier. Parallel runways add a letter suffix to distinguish them. 2 runways pointing in the same direction at the same airport cannot both be called runway 27. The air traffic controller and the pilot need to know which one. The convention is L for the left runway, R for the right, and C for center when 3 parallel runways exist. A major hub airport might have runways designated 28L, 28C, and 28R, all pointing in roughly the same direction, differentiated by their lateral position. Pilots and controllers use these designations constantly. Confusion between 28L and 28R at a busy airport is a serious safety concern, and the phonetic simplicity of the left-right center system exists specifically to minimize the chance of mishearing a single digit under radio noise or accent interference. When more than 3 parallel runways exist, a situation that arises at only a handful of the world's busiest airports, the numbering convention adjusts. Atlanta's Hartsfield-Jackson International has 5 parallel runways. To avoid the ambiguity of having more than 3 runways with the same number and only 3 available letter suffixes, the airport uses slightly different numbers for adjacent runway pairs. Runways that are physically parallel but designated with numbers 1 apart, 09L/27R and 10R/28L, for example, are a visual signal to pilots that the airport has more parallel runways than the standard left-center-right system can accommodate. The choice of magnetic north rather than true geographic north as the reference point has practical roots. Aircraft navigation has historically relied on magnetic compasses as the primary heading reference. A compass needle aligns with the Earth's magnetic field, not with the geographic axis of rotation. For most of aviation history, magnetic heading was the heading a pilot could read directly from the primary instrument in the cockpit without any correction factor. Aligning runway designations with magnetic north meant that a pilot could fly the runway heading by reading the compass directly. The number on the runway matched the number on the instrument. This convenience introduces a complication that takes decades to become visible. The Earth's magnetic field is not static. The magnetic North Pole is not fixed at a single geographic location. It moves, driven by fluid motion in the Earth's outer core. The rate of movement varies, but over the past century the magnetic North Pole has drifted from northern Canada toward Siberia at an average rate of tens of kilometers per year. In recent decades, that drift has accelerated. The consequence for runway numbering is slow but unavoidable. As the magnetic pole moves, the magnetic declination at any given location on the Earth's surface, the difference between magnetic north and true north, changes gradually. At most locations, this change is small enough to ignore for years or decades. But eventually, the accumulated drift causes the magnetic bearing of a runway to shift by enough that the existing runway number no longer accurately represents the actual magnetic heading. At that point, the runway must be renumbered. Renumbering a runway is not a simple matter of repainting the threshold numbers. Every instrument approach procedure for that runway is referenced by runway designation. The standard instrument departure routes and standard terminal arrival routes that connect the runway to the airway network use the runway number in their titles. Aeronautical charts, airport diagrams, instrument approach plates, airline operations manuals, and air traffic control procedures all reference the runway by its designation. Changing the number triggers a cascade of updates across every document and database that references that runway, a process that requires months of planning and coordination between the airport authority, the national aviation regulator, the air navigation service provider, and the airlines operating there. The cost and complexity of renumbering has led some airports to delay the process beyond the point where the existing designation is strictly accurate. The accepted tolerance in most countries is that a runway number can remain unchanged until the magnetic heading deviation from the designated number reaches a threshold of 5 degrees or more, at which point the discrepancy becomes large enough to create potential confusion during instrument approaches in low visibility. Within that tolerance, the practical inconvenience of renumbering outweighs the navigational benefit of an updated designation. Seattle-Tacoma International Airport completed a runway renumbering in 2020, changing its primary runway pair from 1634 to 1735 to reflect the accumulated magnetic drift since the previous renumbering. The operational disruption involved updating thousands of documents, retraining controllers and pilots on the new designations, and repainting not just the runway threshold numbers, but the associated taxiway markings and signage that reference runway designations throughout the airport. The physical runway did not move. The direction it pointed did not change. Only the magnetic measurement of that direction shifted enough to require an updated label. The relationship between runway numbering and magnetic variation also explains why different airports in different parts of the world have runway numbers that seem inconsistent with their geographic orientation to a casual observer. An airport in Alaska, where magnetic declination is large and changes significantly with latitude, may have runway numbers that differ substantially from what a visitor would expect based on looking at a map oriented to true north. The numbers are always correct relative to the magnetic compass. They may simply reflect a magnetic north that points in a different direction than the geographic north a map reader expects. The physical markings on a runway threshold include more than just the designation number. The centerline stripes, touchdown zone markers, aiming point markings, and threshold bars are all standardized elements that provide approach guidance independent of the runway number. But the designation number is the first element a pilot identifies during a visual approach, confirming that the runway ahead matches the clearance received from air traffic control. A mismatch, arriving at a runway and seeing a different number than expected, is an immediate flag to discontinue the approach and verify position. This has prevented wrong runway landings on multiple occasions when a pilot's situational awareness was degraded by weather, workload, or distraction. The simplicity of the runway numbering system is part of what makes it effective. A 2-digit number, readable from the air, that encodes the runway's magnetic heading to within 5 degrees of accuracy, supplemented by a single letter when lateral disambiguation is needed. No codes to look up, no databases to query, no conversion required. The number is the information. For a system that has to work reliably for every pilot, at every airport, under every weather condition and cockpit workload scenario, that directness is a design feature rather than a limitation. The instrument approach procedure attached to a runway designation is worth examining in more detail because it illustrates how deeply the two-digit number is embedded in the operational infrastructure of aviation. An instrument approach procedure, an ILS approach, a VOR approach, a GPS approach, is a published, charted flight path that guides an aircraft from the en route airway structure down to a point close enough to the runway for the pilot to complete the landing visually. Each procedure is designed for a specific runway at a specific airport and is referenced by the runway number in its official title. When Seattle changed runway 16L to 17L, every ILS approach procedure, every localizer approach, every RNAV approach that had been designed for that runway had to be reissued under the new designation. Air traffic controllers who had spent years issuing clearances for the ILS runway 16L approach had to transition to the ILS runway 17L approach. The underlying geometry of the approach, the glide path angle, the localizer course, the missed approach procedure, did not change at all. Only the name changed. But in a system where precision and standardization prevent accidents, a name change requires the same rigor as a physical infrastructure change. Pilots transitioning between airports in different countries encounter variations in magnetic declination that can be significant. An airline operating routes between Europe and North America crosses regions where magnetic declination varies from a few degrees to more than 20 degrees. The runway numbers at each end of the route are calibrated to local magnetic north, which means a runway that appears to point in the same geographic direction as another may carry a completely different number. This is not an error. It is the system working correctly, providing locally accurate magnetic heading information at each airport. The two digits at the runway threshold are one of the oldest standardized elements of aerodrome design, still in use in essentially unchanged form. The core convention, magnetic heading divided by 10, rounded, was established in the early decades of instrument flight and has remained stable as aircraft, navigation systems, and airports have transformed around it. GPS navigation, synthetic vision systems, and head-up displays have changed how pilots interact with the runway environment. The number at the threshold has not changed at all. It does the same job it did 70 years ago, in the same way, for the same reason. And as long as aircraft navigate by magnetic heading and airports have more than one runway, it will continue to. The numbers painted at the end of the runway you land on tonight were calculated from a magnetic compass bearing, rounded to the nearest 10 degrees, and divided by 10. They may have been repainted several times since the airport opened as the Earth's magnetic field drifted. They will be repainted again, eventually, for the same reason. The pavement does not move, the direction does not change, but the planet's magnetic field is in constant slow motion, and the two digits at the runway threshold have to keep up with it.